g of x, so they're just trying to trick us there. So I really have g of x squared. Does everyone agree that's really what that is? Mm-hmm. And so what's the derivative of g of x squared? Oh, sorry. This is f of x. And then the derivative of that is g, right? So this is g of x squared times what? And so the answer is D. Any questions about that one? So the derivative of that was g. So that's the derivative outside, and then you multiply by the derivative of the inside. That's a real AP problem. That makes sense. Okay, this says one final example. I actually have one more. I have another slide. So suppose h of x, so the table problems. You know the table problems, you're probably wanting to see how to do those. We've done them a little bit with product and quotient. The first two are actually product and quotient. So if I were to find h prime of x at 2, h prime on the first one is a product rule, so I'm going to do left, b right, plus right, b left. Let's see how I got that. Or, I'm going to plug in 2. So f of 2 is 3. G prime of 2 is negative 3. G of 2 is 4. F prime of 2 is 5. So I get negative 9 plus 20 or 11. So that's part A. Any questions about a product rule with a table? They will do these problems on the AP exam. Every year there's 1 or 2 of them. I think that's a good thing. That means those are points we can pick up, points that I feel like are not too terrible if you've been exposed to the problems. They're a little tricky if you just haven't seen them before. And you have to remember the AP exam is a curved exam, and you are competing against people who've never seen problems like that before. So that's good news for you. Because a lot of times you have teachers who don't teach AP problems, so they've never seen something like that. Okay, part B, low, D high, minus high, D low, over low squared. F3. G of 3 is 4. F prime of 3, oh, I lied, it's 2. F prime of 3 is 11. F of 3 is 8. G prime of 3 is 14. G of 3 is 2. Any questions so far? So we got 22 minus 112. That's a bit. And was that 90 divided by 4? Is that right? Reduces to 45 over 2. Oh yeah, it is. Thank you. Any questions on that one? The last one, which is really the new thing of the day, is f of g of x. The derivative of f of g of x would be f prime of g of x times g prime of x. I am going to do a little more work this time. Up there I didn't fill anything in, just plugged it in. I want this value at 3, which is f prime of g of 3 times g prime of 3. Everyone see what it is? So I'm going to work from the inside out on a composition decomposition of functions, I'm going to go find g of 3 first. And what is g of 3? 2, which is really great news. Of course, they made it that way because 2 is still on the table. If it weren't, the answer would be undefined. Like it wouldn't be defined. If there was a value in there that you couldn't find on the table, then the answer would just be undefined. F prime of 2 is 5, and G prime of 3 is negative 14. Positive source. And that's 70. Right. Any questions? Okay. So that's how you do the table problems. Do those make sense? There are actually quite a few of those on your homework, and it's because they show up on the AP exam. This slide is a nasty slide. This is, let's do the chain roll as bad as the chain roll gets to see how bad we can make it, okay? Some of them are, and it's just to get you to practice those nasty chain roll problems. This is a slide that should help you with those nasty homework. You won't have to do a ton of those on the AP exam. They will show up. They will be on your mastery exam that you get. I'm probably going to go ahead and hand a copy of that out Monday. Maybe tomorrow, sometime. For your take-home copy, and then we'll grade that before you have the actual exam. I am going to try to give you the mastery exam before the test. Start it before the test, even if we haven't even finished all the material yet. And the reason I'm doing that is I did that last year in my trig calc class because I had to. They were in the spring. I had to shove it in early to get it in before my weeks. And they did so much better on their exam because they had already mastered the rules. And so I decided that was a thing I was going to steal in this test. May need to steal it for our spring also, because I just gave that test in my BC calculus class. And the people who mastered the exam before the actual test, of course, did better on the test. So I'm going to try to steal that as much as I can anyway. Okay, so find the derivative. So to do that, I've got to work on the outside function first, right? So the derivative of the outside is going to be that green part. And I'm going to leave the inside completely alone. Then I'm going to do the derivative of the inside. It turns out that part of that inside has an inside. So we've got multiple chain rules happening here. So I'm going to do the derivative of the inside. This first piece, that derivative is 5x squared plus 3 to the 4th. I left the inside alone. But then what do I need to multiply by? 2. And then I'm going to add the derivative. This is nice because it's just addition. The derivative of x is 1. So that was pretty nasty. I'm not going to simplify it. You could, but I'm not going to. Any questions about that derivative?
So we don't have to take out like the x squared plus 3 at all?
No, if you really wanted to do something, you boil these together.
But like that's the derivative.
That is the derivative.
What about 2x?
When I took the derivative of this piece, so you just look at it alone, ignore put blinders on, and ignore everything else. The derivative of that is a chain rule. So the derivative of that is that one was happy. What is the next one? A product rule, right? The next one is a product rule. I have a left-hand function, sine go for it. That's not a problem. Any questions about that? No. It looks like you have. I was waiting on that.
I'm like,
That looks like a question.
faster.
Yeah, I mean,
Because you're not done.
and then right, D left. D left is a chain rule, so I have a times 4 on that. So this is the right hand piece. This is the derivative of sine of 4x, which the derivative of that is cosine of 4x times 2.
Oh, it's always because it's not just the x.
Yep.
So if we did it the other way, like start from the beginning, like line x, how would it work? Can you do that?
No, because it's not, the 4 is not the power, it's just a sine of 4x.
So you can only move it when it's like sine of the power.
Right, except for we're up here, that's when we do that. Like this. That would. So before I do anything on this one, Kelsey's saying if I've got a power, I need to rewrite it. Because it really lets me know where my inside and my outside functions are. Any questions so far? So the derivative of the outsidemost function is 2 to the first power. Now we're going to leave the inside completely alone. Then I'm going to move into the derivative of the inside. And what is the derivative of sine of 3x? See, we actually got kind of a 3-part table.
I think those are the words we just check off that you do.
Mhm.
You never really always forget where you are.
Yes, they do get tricky. This one's, yeah. Okay, before I do anything, what would you do to rewrite the exponents as fraction exponents? And I have 2 plus, okay, this is the 1/2 power, that's that big square root. And then I have the 2 plus x to the 1/2. Notice that.
I don't think that would really happen.
Now, first time. Do you see that now? The outside square root has a 1/2 power. The middle square root does 1/2 power, then the x to the 1/2. You could rewrite it in steps if you needed to. You wouldn't have to do it all at once. If you needed to start it inside, rewrite the x to the 1/2. You needed to do it more than one step. Outsidemost function. I'll leave everything on the inside. Okay, so far. I'm going to do the derivative of the inside. So the black part, I'm going to do the derivative of that. The 2 is nice because it's the derivative of 2. 0, so that part just goes away. So I'm really looking at this piece. do a rewrite on this, but just for fun, to show you what this means. All those 1/2 are on the bottom, agree? So it's really 1/8 on the bottom. 8. It's 2, 2, and 2. There's one here, here, and here. All multiply together. And then this would be a square root on the bottom. This would be a square root on the bottom. And that would be a square root on the bottom. But for some reason, we wanted to write that out